All right, welcome everyone. We're diving deep into NVIDIA today and everything they revealed at CES 2025. So we're breaking down Jensen's keynote to figure out, what they announced and why it all
Well,
matters.
NVIDIA's journey has been fascinating to watch, especially as computing has evolved. I mean, they started with gaming,
Yeah.
right, pushing the limits of what graphics could do. Then they really revolutionized computing with programmable GPUs and CUDA, and now they're leading the charge in AI,
Yeah,
which is transforming everything
yeah.
from CPUs to software and even hardware design.
Yeah, it really feels like they've come full circle. They started with visuals and now they're using AI to create them. Speaking of visuals, let's start with the new GeForce RTX 50 series for gamers. What makes this different from previous generations?
Well, the Blackwell architecture behind the RTX 50 series, it's a huge leap forward. Just to mention this, most of the pixels you see in real-time graphics are now being generated by AI. So in the scene with, say, 33 million pixels, only about 2 million are actually computed.
Yeah.
The rest are predicted by AI.
So instead of calculating every single pixel, the AI just fills in the blanks. That's incredible. What does that mean for, gamers in practical terms?
Well, it means incredibly powerful graphics on devices that wouldn't normally be able to handle it. So we're talking about, high-quality gaming becoming accessible on thinner laptops and more affordable PCs. Plus, the new 5070 offered the performance of the top-of-the-line 4090, but at a fraction of the cost.
Oh, wow. That's great news for anyone looking to upgrade their gaming setup. But this AI revolution goes way beyond just gaming, right? Jensen talked a lot about the scaling laws driving AI evolution.
Yeah, he did. There are three key scaling laws: pre-training, post-training, and test time scaling. You can think of it like building a skyscraper. Pre-training is laying the foundation with massive amounts of data, larger models, and more computational power. The bigger the foundation, the taller the building can be.
So pre-training kind of sets the stage for what AI can do. What happens in post-training then?
Well, post-training is like constructing the floors of the building. Techniques like reinforcement learning and human feedback come into play to refine the AI's skills. It's kind of like a coach training an athlete. Constant feedback leads to better performance.
So the AI isn't just learning from data, but it's also learning how to learn more effectively. That's fascinating. What about test time scaling then?
Well, that's where we furnish the building and put it to use. It's about the AI becoming more efficient at allocating its resources and thinking more deeply when it's faced with a problem.
So the AI isn't just following instructions at that point. It's actually analyzing the situation, figuring out the best approach. It's almost like it's developing critical thinking skills.
Exactly. It breaks down a complex problem into smaller steps, considers different solutions, and then chooses the most effective one. And this is where AI starts to feel more human-like in its problem-solving abilities.
To handle all of this increasingly sophisticated AI, NVIDIA also unveiled their new GB200 supercomputer. What makes this system so special?
Well, the sheer scale of it is mind-boggling. It weighs 1.5 tons, has 600,000 parts, and requires 2 miles of copper cable. In training these massive AI models, it demands incredible amounts of power.
2 miles of cable. It sounds like it needs its own zip code. But what does all of that translate to in terms of performance?
Well, it boasts a 4x improvement in performance per watt and a 3x improvement in performance per dollar compared to the previous generation. And this incredible efficiency is crucial for data centers, which are the backbone of the internet and AI development.
So we're talking about some serious progress in AI, both in how it learns and the hardware that powers it. But what does this all mean for everyday applications? Huang also talked about something called agentic AI, which sounds like AI straight out of a science fiction film.
Right. Agentic AI is essentially a system of AI models working together to perform complex tasks. They can reason, they can break down problems, retrieve information, use tools, and provide sophisticated responses. Think of it as a digital workforce capable of handling, increasingly demanding jobs.
So instead of just responding to commands, these AI agents can actually figure things out on their own, almost like a team of digital assistants.
Precisely. And NVIDIA is building the tools to make this a reality. They have NIMs, which are AI microservices, and NEMO, a platform for training and managing these AI agents, like digital employees.
So IT departments might soon be managing AI employees alongside their human counterparts. It's like the future is arriving faster than we thought. So it sounds like we're on the verge of a major shift in how we work and interact with technology. But how does this agentic AI impact our personal lives? Are we talking about AI taking over our PCs?
It's not really about takeover. It's more about empowerment. NVIDIA is focusing on turning Windows PCs into powerful AI platforms.
Yeah.
Using something called Windows Subsystem for Linux, or WSL2.
WSL2, yeah, that sounds familiar. I need a refresher, though. What is it exactly, and how does it relate to AI on my PC?
Imagine a bridge connecting your Windows PC directly to the vast resources of the cloud. That's essentially what WSL2 does. It lets developers run Linux environments, where a lot of AI development happens right inside Windows.
So developers can build these AI agents in the cloud and then seamlessly deploy them to Windows PCs through WSL2.
Exactly.
Oh, yeah.
And NVIDIA is providing all the tools developers need to make this happen, things like NIMs, NeMo, and even ready-made blueprints, all optimized for Windows. They're really making Windows a first-class citizen in the world of AI development, alongside the cloud.
So instead of AI being this distant concept in data centers, it's actually becoming integrated into the devices we use every day. That's pretty remarkable, but NVIDIA isn't stopping there, right? What about Project Digits?
Oh yeah, Project Digits is all about democratizing access to AI hardware. So imagine having your own personal AI supercomputer, compact and powerful enough to handle demanding AI tasks right on your desk.
A personal AI supercomputer. That sounds like something straight out of a sci-fi movie. What's powering this incredible device?
Well, it's powered by a custom chip called the GB110. It's a Grace Blackwell processor developed in collaboration with MediaTek, a company known for its mobile chips.
So with Project Digits, you could have a personal AI cloud and a powerful Linux workstation, all in one compact device. That's a game changer for researchers, developers, really anyone interested in exploring AI.
Exactly. But, AI's reach goes beyond just the digital realm. NVIDIA is also pushing the boundaries of what they call physical AI and its impact on robotics.
Physical AI. So we're talking about AI that can interact with the physical world. This sounds like we're moving into the territory of robots and self-driving cars.
You're right on track. Physical AI is all about AI understanding and navigating the real world. And NVIDIA's answer to this challenge is Cosmos.
All right, Cosmos, lay it on me. What exactly are we talking about here?
Imagine an AI that spent 20 million hours watching videos of the real world, objects moving, interacting, following the laws of physics. That's Cosmos. It's the world's first physical AI foundation model.
20 million hours of video. That's more video than any human could possibly watch in a lifetime. What kind of knowledge is Cosmos gaining from all of this data?
It's learning the fundamental rules that govern our physical world. Things we take for granted, like gravity, friction, inertia, spatial relationships, cause and effect, even object permanence. These are all incredibly complex concepts for AI to grasp.
So Cosmos is essentially learning how the physical world works, just like we did as children, but at an accelerated pace. What are the implications of an AI that understands physics?
Well, the possibilities are vast. This understanding can revolutionize fields like synthetic data generation, training robots to interact with the real world, and even advancing multimodal language models that can understand not just text, but images, video, and sensory data.
So it sounds like Cosmos is laying the groundwork for AI to become much more integrated with our physical reality. But how does this connect to NVIDIA's Omniverse platform, which focuses on creating virtual worlds?
Well, that's where things get really exciting. When you connect Cosmos to Omniverse, you get physically grounded AI generations. So the AI can create virtual scenarios that not only look realistic, but they also behave realistically, following the laws of physics.
It's like creating a virtual sandbox where AI can experiment, learn, and refine its understanding of the real world before it's deployed in, physical robots or self-driving cars.
Precisely. And this combination is incredibly powerful, especially for robotics where safety and accuracy are paramount. It's about minimizing risk by having the AI practice in a virtual world before it interacts with the real one.
This is starting to feel like those sci-fi movies, where AI learns in simulations before being unleashed into the real world. But speaking of robots, Jensen also talked about a three-computer revolution in robotics. Can you explain what he meant by that?
Sure. He believes that we need three types of computers working in harmony to create truly advanced robots. First, we have the DGX, the powerhouse for training AI models. This is where the AI learns from those massive data sets.
So the DGX is like the teacher, imparting knowledge to the AI. What about the second computer?
The second computer is the AGX, the AI brain that resides inside the robot itself. Whether it's a humanoid robot or an autonomous vehicle, it's the one making real-time decisions and controlling the robot's actions.
So if the DGX is the teacher, the AGX is the student putting that knowledge into practice. What role does the third computer play in this revolution then?
Well, the third computer is where Omniverse, connected to Cosmos, comes into play. It acts as a digital twin, a virtual world where the AI can be tested, refined, essentially put through a virtual boot camp before being deployed into the real world.
It's fascinating to see how these three computers work together to create a complete ecosystem for developing and deploying advanced robots.
NVIDIA is already putting this three-computer strategy to work in real-world applications, particularly in warehouse automation. They're partnering with companies like Keynote and Accenture to bring physical AI into warehouses and distribution centers.
So are we talking about robots replacing human workers in warehouses?
Not necessarily replacing, it's more about collaboration. These AI-powered robots are designed to optimize workflows, manage inventory, even handle complex tasks like picking and packing orders. And all of this happens within a virtual twin of the warehouse created in Omniverse.
A virtual warehouse. That's incredible. Why create a virtual replica of a physical warehouse?
It comes down to safety and efficiency. Imagine being able to test different warehouse layouts, optimize robot paths, identify potential bottlenecks, all within a safe, simulated environment, but before implementing them in the real world.
It's like a giant sandbox for designing and testing the most efficient and safe ways to operate a warehouse. It sounds like a win-win for both the company and the worker.
Exactly. It's about reducing downtime, minimizing errors, and ultimately making warehouses run more smoothly and productively. This three-computer strategy has the potential to revolutionize not just warehouses, but entire industries where robots can work alongside humans to achieve better outcomes.
So it's amazing to see how this three-computer approach is already transforming industries like warehouse management. But I'm also curious how this technology translates to another area where NVIDIA is heavily invested: autonomous vehicles.
Well, autonomous vehicles are a perfect example of how NVIDIA's three-computer strategy can revolutionize an industry. They're not just building the chips that power these vehicles, they're creating the entire ecosystem for development and testing.
So they're taking that same approach, the DGX for training the AI, AGX for the in-car intelligence, and Omniverse for simulation and data generation, and applying it to the world of self-driving cars.
Precisely, and they're partnering with a whole range of companies, from established players like Waymo and Tesla to newer entrants like Lucid and Rivian.
Yeah.
They even announced a new partnership with Toyota today for their next-generation autonomous vehicles.
It sounds like NVIDIA is quickly becoming the industry standard for autonomous driving technology.
Yeah.
What kind of progress are we seeing in this field? Are we getting closer to, truly self-driving cars on our roads?
We're definitely making strides. NVIDIA's Drive OS, their software platform for autonomous vehicles, it's a major success story. It's the first AI computer to receive certification for automotive functional safety, meaning it meets the highest safety standards.
Safety is obviously paramount when we're talking about cars driving themselves, but what about performance? What kind of computing power is needed to make these vehicles function safely and efficiently?
Well, they just unveiled their new AV computer, Thor, and it's a game changer. It has 20 times the processing power of their previous generation Orin chip, which was already an impressive piece of technology.
20 times more powerful. That's a huge leap. What's the reason for needing so much computational power in a self-driving car?
It's all about processing the massive amounts of data coming from the car's sensors, cameras, radars, lidars. The AI needs to make sense of all this information in real time to navigate safely and make split-second decisions.
So Thor is like the brain of the self-driving car, constantly analyzing its surroundings and reacting to everything happening on the road. And, remember those digital twins we talked about earlier? Do those play a role in the development of autonomous vehicles?
Absolutely. NVIDIA is using AI to reconstruct digital twins from real-world driving data, creating this vast library of virtual roads and driving scenarios. This allows them to generate massive amounts of synthetic training data.
Synthetic training data, why is that so important for self-driving cars?
Think of it as giving the AI driver's ed in a virtual world. By simulating millions of miles of driving in diverse conditions, rain, snow, traffic, even rare edge cases, they can expose the AI to a far wider range of scenarios than it would ever encounter in real-world testing.
It's like creating a virtual driving school for AI, where it can learn from every possible situation before hitting the real roads. This sounds like a much safer and more efficient way to train self-driving cars.
Exactly. It's about accelerating the development of safe and reliable autonomous vehicles. They're essentially turning thousands of real-world drives into billions of simulated miles, creating a sort of AI data factory for training self-driving cars.
It's incredible how all of these different technologies are coming together to create the future of transportation. Speaking of the future, what about humanoid robots? Are we any closer to having robots that can assist us in our daily lives?
Humanoid robots are definitely on NVIDIA's roadmap. And they've just announced a new platform called Isaac Groot to accelerate their development?
Isaac Root, is that a reference to the Guardians of the Galaxy character?
Perhaps. But it's also a powerful platform for building and training robots that can perform a wide range of tasks. It provides robot foundation models, data pipelines, simulation frameworks, and even a Thor robotics computer to power these sophisticated machines.
So it's a complete toolkit for developing humanoid robots. What are some of the challenges in creating robots that can, function effectively in our complex world?
Well, one of the biggest hurdles is training robots to handle the countless tasks we take for granted as humans. It requires a vast amount of data, and capturing all those human movements and interactions is incredibly time-consuming and expensive.
So how is NVIDIA tackling this challenge? Is synthetic data generation part of the solution here as well?
You guessed it. Isaac Groot uses AI and Omniverse to create massive amounts of synthetic training data from limited real-world demonstrations. They're even using Apple's Vision Pro headset to capture human motion data and use it to train the robots.
So they're teaching robots by example, but in a virtual world. Multiplying the amount of training data they have, this is really pushing the boundaries of robotics.
It is, and this approach could lead to a future where humanoid robots assist us with everything, from healthcare to manufacturing to daily tasks in our homes.
This has been an incredible deep dive into the world of NVIDIA and their vision for the future. Can we recap the key takeaways from Jensen's keynote?
Of course. NVIDIA is focused on three core areas. Powerful AI foundation models like Cosmos that are changing how we interact with the physical world. The three computer robotics strategy that's revolutionizing how we build and train robots, and the democratization of AI through initiatives like WSL2 support and Project Digits.
It's clear that NVIDIA is all in on AI, but what does this mean for us, the everyday users of technology?
Well, the implications are far-reaching. We're on the cusp of a new era where AI seamlessly integrates into every aspect of our lives. From the games we play to the cars we drive to the ways we work and learn, AI is poised to transform our world. It's an exciting time to be alive, and the pace of innovation is only accelerating.
It's both exhilarating and a bit daunting to imagine the possibilities. Thank you for taking us on this journey through the world of NVIDIA and the future of AI.
It's been my pleasure.
And for all of you listening, we hope you found this deep dive informative and thought-provoking. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in this incredible age of AI.